All right, the countdown has begun, so that means we start. Thank you all for being here. I'm so excited to be at Kotlin Conf. I've watched it online many times, never got to come. Finally here, and you're here at one of the last sessions, so thank you very much. Give yourself a round of applause. Hopefully this will be enjoyable. I know I've had a good time preparing for this, and today we're going to talk about the dynamic exploration of static analysis with Compose. It's a big thing. We're going to break it down, though. My name is Sam Edwards. You can find me online as Handstand Sam. This handstandsam.com is where I do tech blog posts about Android and Kotlin and things on threads, on what used to be Twitter and things like that. So this was this morning. See, same shirt, same jeans. But I had to go check it out. I've been at the conference the whole time. So, okay. So like I said, it's like having a mouthful, the big title of what we have going on here. So I did present this internally at our company on Monday, and they were kind of like, that was cool, but like it was like this, man. Like, what's going on? So I tried to pull out the parts that were important, and I created a storyline. So that's what I'm going to walk you through today. I'm going to take you through a story, and through that, I'm going to do live demos. I'm going to show examples, teach you cool stuff. So this starts 10 months ago, exactly today. So I joined the Android Foundation team at Square. It's a small team, but the responsibility is basically like every foundational piece that the feature developer will need. So module structure, dependency injection, libraries, like kind of have everything set up for you. And so I was super excited to join this team. We all use Square libraries probably in our apps, and to be part of that team was something that I was really excited for. So I wanted to show up, I wanted to do a good job, and I got my first task. And so it was kind of written out. It was like, as an Android developer, I want to know which development apps exercise the impl Gradle modules my team owns. That look in your eyes is what I felt like when I saw it. So let's break it down. They wanted me to know what development apps, so we'll figure out what that is, exercise the impl Gradle module that a team owns. So there's three pieces there that I have to figure out. I already know about ownership. I've done that before at other places. I don't really know what an impl module is. I don't really know what a development app is. So when you onboard at a company, you go search their internal documentation somewhere, and you find something on module structure, which is probably going to tell me what a development app is and stuff like that. So I start reading through, and I'm like, this is very familiar. Why is it familiar? Oh yeah, Ralph used to be on this team, the Android Foundation team at Square, and he did this talk 4.5 years ago at DroidCon San Francisco. So I had already heard about this, the module structure. I kind of like started ringing a bell, and so this is actually a screenshot from his slide from 4.5 years ago, and it still is true. So a development app at Square is a small isolated app that allows you to develop and test your feature in isolation. So basically fake out everything that you need, but just satisfy the dependencies you need and develop your feature without building the entire app. So internally, sometimes it used to be named as a demo app, but these are development apps. And with the module structure that's laid out, and you can watch his talk if you wanted, these demo apps are the development apps. They relied on impl wiring modules, which actually don't really exist anymore. That was required for Dagger to basically say this dependency binds as this. But instead we use Anvil now, which is something that our team authored, and use your implementation. And so in there you can actually use Anvil to go ahead and do the wiring for you. But yeah, these development apps, they're for this purpose. So check, I know what a development app is. And then I kind of know what an impl is here. So I asked more questions. It's like, what is an impl? And so one of the features of Square, which is like a point of sale, a lot to do with sales. So one of the things is a checkout feature. So the checkout feature we'll use as an example here, and they have implementation modules. So really the question was here is, hey, somebody on the checkout team, they want to know which development apps and where in the code base they're being used. And you might say like, well, that's easy. But when you have thousands of modules and you have multiple targets, it isn't super easy to know where you're being used. So that was what they wanted to figure out. I have a plan. Or so I thought. So I had authored this library like 1.5 years or 2 years ago. It is a library that resolves all of your dependencies for modules transitively, and then has a baseline file. If something changes, it'll tell you what changed and kind of surface all these unintentional dependency pop-ups. But in doing this, it's open source. I have the code I need to traverse the dependency graph to get to get all of the transitive dependencies for a certain configuration. So I have to figure out who depends on what, and I can't just look at who the development app relies on, because that can rely on something else, and you know how dependencies work, so this is gonna be an important part of this, so I could use that same logic. Open source is great. You can use code you've written before, even when you're somewhere new. Custom Gradle plugin and tasks. So this is the way I approached it, the same way I've written Gradle plugins before. When you do this, I had to configure the project. Configuring the project basically means running all the Gradle build logic and everything else to figure out what's really happening there. And when you do that, you now have access to resolve all of those transitive dependencies. It knows what repositories it's pulling from, what relies on what, and then you can walk that tree and get that information. And finally, you execute the task that does that, and you spit it out somewhere. So I'm like, all right, cool. I got all the data I need, and here's my first prototype. And this is a screenshot from one of the Slack messages that I had sent. It's very fuzzy. But basically, this is just every demo app that we had. I went ahead and created a text file. And that text file said, here's, like, each line was a dependency. And so I had actually like almost 300 text files. And so theoretically, if somebody did a find on that directory and they said, which one of these files am I a part of, my impl module, they could figure it out. But that's not a good experience, right? Like if you want to send that out to a feature developer, they're not going to be able to figure that out very easily. So we can do better, right? Also, I realized those flat files, I was only using the debug configurations. Did you remember that there's runtime, there's test configurations, release, debug, Android test, there's all these different configurations. And on each one of them, you can set dependencies differently. So you might set like a fake on a test, and you might set a real one somewhere else. And so this is also coming into play, because if I'm doing dependency analysis, I kind of want to be holistic. I want to know all of it. So the Gradle plugin, I decided we're going to go ahead and spit it out as JSON, right? So I can kind of capture everything in this like nice structured like data class and then just dump it to JSON. And so that was great. But now I have this JSON blob that has all the information I need, all the configurations, but I still haven't allowed them to answer that question. So what do all of us do when we need to answer a question? We use React.js. And so I tried. You know, I went, you know, every web developer I've talked to that's passionate about web development really loves React.js. And I've listened to Leland Richardson, which is on the Google team and works on Compose, used to be a core contributor at React, and said a lot of those things came over. And I wanted this to be an interactive report that could go ahead and be hosted like on a web page or something so somebody could figure this out. So I tried it, and I got it to work, and that was great. But I didn't really understand what I wrote. And I realized if anybody else was going to update this later on, they probably wouldn't know React either, because it's not a skill set that our team had. So then I thought, what about, well, we did React. What about Kotlin multi-platform? So we could use Compose multi-platform by taking that Gradle plugin, going ahead and using the shared data models that we already have using Kotlin X serialization, and then on the opposite side, I used the desktop Compose app and built it. And it was great. You could visualize what was going on. You could see the dependencies. You could write queries. But then I thought, well, how am I going to send this to a developer? Are they going to download this huge jar file and then run Java jar and like start this thing? Do I have to like have some sort of app store to send it around? Didn't really seem like it was going to work to be something I can quickly go look up and see who's using my feature. So I went to Wasm. And man, was this cool. This was last September. Like, it was kind of even hidden at the time. But I figured out it was there. I used the Material 3 APIs for Compose multi-platform, and like there's a Jet Snack demo they had, and I kind of cloned that repo, and I was able to get the Wasm target working. So this is actually a screenshot of it working. And wow, I was like, this is cool. This is in the browser. This is awesome. I think there's a lot of future for Wasm. So much so, I wrote a blog post last September that was like, this is great, love it. You know, I've tried other things before, but I was really excited about it. And this is how it worked. So this is the UI. You had a text input box in the top corner, and then you decided, like, because we have thousands of modules, you type in your, like the prefix of your module, and then it would start auto-completing. And so based on the thousands of modules, it realized that there are 36 things that actually use that, that match that prefix. And then out of those 36, I'm scanning all of those. I'm seeing which apps they're using. I'm realized that there's 25 development apps that use those. And so if you kind of go back to those 36 before, what's important is I knew there was like a checkout feature developer, but they have lots of little implementations in here. They have buttons, edit mode, full cart, all these other things. It's still part of their feature, right? It's something that people exercise. So you want the ability to not only look at one, but maybe a lot of them. So super excited. So this, yeah, again, last September, I'm just giving context to the time period of when I tried this out. I sent it to somebody on the mobile developer experience team, and I was like, check this out, isn't this cool? Wasm is great. And he said, I can't paste. And I was like, but it's cool, right? He was like, yeah, it's cool. But how do I copy the results? It shows me what my modules use me and stuff, but like it just showed on the screen. I can't get it. It's like, but it's cool. It's cool technology, man. But anyway, you can't make a technology solve. It's not always perfect for every problem, right? And so Compose Wasm, even though it would be available for anybody to use, like if I just had a static site that I posted every time something landed in the main branch, it's all up to date. It still just like didn't give the experience that we wanted. However, as of yesterday, Wasm is now in alpha. And guess what they did? They worked on keyboard input. So maybe it's better now, but I still think selecting the text might not be working, which is what I need in this use case. So if you remember, Compose HTML was like before Kotlin, before Compose multi-platform. But it allows you to use Compose, use your composable annotations and everything, but you actually use HTML DOM elements underneath the hood. So I chose this so I could create a website, but it was still going to be built in Kotlin. It could be modified and used by any of our developers, and they could still operate on everything as, like, there's flows, you're collecting state, you have composables. It's just at the end and the rendering layer, and when the data's loaded, that's where you're like interacting with the native code base. So it seemed like a better solution. So a big part of this is I wanted this report to be automatically generated every time the code updated, so I never had to do it again. And so I wanted to publish to GitHub pages, so it's accessible from anywhere whenever they want. It has that copy-paste support. It doesn't require a backend. This was big because I thought about that, and I was like, why? It's just so much work to stand up a backend. Where am I going to do it? And if I want this to be a tool that can be shared by others, it just adds an extra layer of complexity. And yeah, I wanted this to be familiar to Kotlin developers, so everybody that used Compose could figure out how this was done. And what did this do? Just like it did in React, it enabled dynamic exploration of this data I had. So as we talked about, I had this flat text file, and I had this flat JSON file, but now I've had this ability to take this analysis that I've done and actually create like a dynamic way of going through it. So, awesome. What I realized was, hey, I could try this on another project. So I tried it, and with a few tweaks, I got it to work on some open source projects. I tried it on Cash App, it worked. I tried it on a few other things, and I was like, oh, this is generally applicable. Like, it is something that works on any Gradle project at this point. So why don't I make it kind of open source? So I got approval for the name Invert. It's not open source yet, but I'm working on it. But yeah, I've named it Invert. And the reason why is it's an inverted view of your Gradle project. So instead of you saying, I am this module, I depend on these things, instead it resolves everything. You get that context. And then you can say, who relies on me? So that's kind of the general thing here, is where you're able to gather all that data and then use dynamic exploration to gain insights. So you'd apply the Gradle plugin, you run the task, and you're done. So this is what it looks like on the open source Android app for DuckDuckGo. It's a pretty large Android app that's out there. It uses Anvil, and I figured, hey, let's try it out on something I can show at KotlinConf. So the AV people were like, how many apps are you going to use? And I was like, all of them. So here we go. Let's see. We're going to go over to, actually, where is that? Here, I had a link on it. Pardon me, demo. There we go. All right, so this is the real thing. I can scroll around. So it's an invert report for this. It was captured, I did New York time because I'm US based, but that's 11 a.m. today. This report was done. And so it's just a general page. It looks just like a normal HTML page, but it's using Compose HTML that renders the JavaScript. And in here, you can have some like general module information. You click on, you could go through here and you can like look for different stuff. Let's look at downloads. I can see some statistics that I've collected as well, lines of code, what dependencies does it have, and what class paths. This is the answer to the problem too, is who uses me transitively. But this is on a per module basis, so that answers the question for one module. But you have all this data now in here. You have, including ownership. I used a GitHub code owners like format to go ahead and try to parse out the owner's information. So each module is owned. So like Craig Russell owns these 4 modules somehow. And yeah, we can click around. Like this chart too, what's nice is because it's using composed HTML, you do a small bridge to an existing JavaScript library and you can use it. So that was really powerful. Yeah, statistics. What I want to show here now, though, this part of the demo is what did we collect that we used in order to create our inverted dependency search? Pardon me. So we used the modules, all the Gradle plugins that were applied, and on the right, this is trying to visualize which plugins you're applying the most. But again, you can sort through all these, the artifacts that are there. So these are not your local code modules, but your third-party artifacts that are brought in. So if I want to look at like activity, I can see I'm pulling in 151, and you might realize, like, why are there 2 versions there? But the reason is it's because based on the different class paths and the transitive dependencies, sometimes it does pull in different versions. What I did cool as well, I feel like, is if you go up and down, you can sort these by any of these columns, or you can hover over this button. It'll say copy all 307 column values. So if you just want to pop it out, you click on that, hopefully, and then you'd hop over to somewhere else in a text editor, and now you have all the artifacts that were in that. Now, maybe I want all the information. So any of the tables I display in here, I made part of that composable. It's just like you say, here's data that I want to display. It has a composable, and now I have this thing in the bottom. And this allows me to download the entire table as a CSV. So I can do that, and I don't know how to view it in here, honestly. But I promise it'll open up in like a CSV editor or whatever. They had me change the screen resolution. Okay, but that opens up, and that kind of gives you, again, how do I consume this data, right? This is one view of it, but I might want to do something else. How do I get it out of there? I could just copy it like this, but it's another way of exploring it. Gradle repositories, what configurations are there that we analyzed, what all of them are, what annotation processors have been applied to this. So this is interesting. Which modules use room? So with KSP, room is applied to these modules. They also have auto service, glide, Dagger, and then we can look at their compiler plugins. And they have KSP, Kotlin scripting, Anvil, and some other things. So really cool now. We've captured all this information, and we've been able to dynamically explore it using a few. All right, so let's keep going. Oh, one of the things I wanted to show was if I click on this, I didn't even show the real tool, sorry. I showed you for a single module, I could see who relies on it. But that original thing that I showed you with the Wasm screenshot, it still exists in here. So this is the search area. You can say, here's the module I'm interested. I'm using downloads as my example. But if this is the case, these 3 modules match out of the 129. And I can see that these 3 libraries and this single app is what relies on me. And I can even expand that out more and see that only the downloads API is used here, not the other modules, and on what class paths they're used and so forth. So it's a really interesting way to explore the relationships of your dependencies. Yeah, so that's what's there. All right, continuing on. ... Okay. Couldn't you have used ChatGPT to do this? But remember, I have an idea. I can do a Gradle plugin. I've done one of those. It's fun, right? It's fun to do technical stuff. But could I have, right? At the beginning of this, I got a task. It said, I need you to be able to answer a question. That is, for your feature, what development apps use you? Why couldn't I have just asked something? That's a simple, plain question. It's structured data. It kind of brings up the whole point. How do I ask my code base a question? Right? We have all this code, and we're running all the static analysis and doing all these things, waiting for our IDE to sync so we can actually ask a lot of questions. Sometimes when we have a question, we just go to IntelliJ search or go to grep or something, or find, and you just search, I need to find all the composables in a Kotlin file. I need to find usages on this because once IntelliJ goes ahead and indexes everything and it actually gains context by parsing the PSI trees and understanding types and things like that, we can actually find usages. We can use all of that related information to go ahead and do really cool features like refactoring and things like that. We can view type hierarchy, we can view code structure, what public methods are there, what variables are defined, things like that. So all of these things are powered by context. Context basically means here's all this information I know about this project. The same way that I was collecting all of this data about dependencies and with Gradle. As long as I have all that, I have something to ask questions to. So IntelliJ's built a series of tools that obviously know how to act on top of that, which is great. So doing analysis creates context. And this is a slide from the keynote yesterday. Svetlana mentioned this, and it was basically the context that they get inside of IntelliJ, which is just really similar to what I was talking about. Dependencies, what files are there, the usages, things like that. I was only like a very small set of that, not the whole thing, but it's still the same idea, right? You need that context to do cool things with your code, to figure out and answer questions. And especially on a code base that has thousands of modules, being able to ask those questions is critically important because there's no way anybody knows everything about the project. So some easy questions you might run into when you're asking your code base a question would be, find the word, let's see, did that show up on the screen? Okay, did down there. Find the word analytics in a file named star.kotlin, or figure out which files have the import Kotlin test. All these things, to answer these questions, all you need to do is do a find, and you can do that with any indexed. You can do that with Finder itself, you can do that with command line. You're literally just searching for text, and that's an easy question. Hard questions. So, is my code formatted correctly? Well, what does correctly formatted code mean? Well, it's your definition of formatted code, but then you need something to understand what code's supposed to look like and apply rules, so that's hard. How do I follow the best coding patterns? Like, am I passing all my lint and detect rules and things like that? Hard questions, can you find the usages of something? What are the concrete implementations, like that type hierarchy view? These are all hard questions, and the only way they're solved is with context, or the answer is with context. But the only way we build context right now in our development cycles are we wait for Gradle to sync, which sometimes takes a long time depending on the size of your project, and then you can ask questions. Hard questions. So to get these, this is very similar to what Svetlana had up there, but you need code structure, you need type resolution, references, and the build configuration to kind of put it all together. But with this information, you can answer hard questions, and you can make really powerful IDE tools, or you could just surface information, like I have in Invert, and like explore it in interesting ways. What if you have multiple hard questions? A lot of you do this. You would go and say, okay, I have an analytics interface here, right? Where are the implementations? Found them. Okay, what modules are those in? Okay, who are the owners of those modules? And then what files are those implementations in? Right, this is a natural progression. This is us going through and exploring our code base, but it's not a run once, get an answer once, right? It's having this knowledge base and this context that you can ask questions to. And so I feel like in the tool that I'm starting to build with Invert is you're gaining some of that context and you're able to make some of those, answer some of those questions. And my goal is not at all to replace anything with IntelliJ, but it's to be able to answer custom questions, really, that can't be solved there. So, yeah, like I said, normally you ask a question, you'd run the analysis and get the answer. But what if we ran the analysis and then we can ask any question we want, right? So that's what we do when we wait for our IDE to sync and index and everything. We're waiting for it, but now we can do it. So we've run all that analysis. And that's what gives us that whole context. Not the Android context. So in this talk, I said we're going to talk about dynamic exploration. Check. We're going to talk about compose. Check. We're going to talk about static analysis. Okay, we forgot that one. So let's dive into there a little bit so we can get all of our checkboxes. Static analysis. Man, ChatGPT is so great. It made me this image. It looks wonderful. I was like, give me a computer screen with static. All right. So what is static analysis? It is the analysis of source code without executing it. So the analysis we've done so far has been using Gradle, running configuration, and pulling things out of that. But we're not really analyzing the source code at this point in time. So static analysis is really analyzing, those Kotlin files or any other files that are there, and then trying to find information about it. Popular tools that you might think of for static analysis would be like detect, which allows you to have rules for best practices in coding, and it will like surface any errors that you might have that break rules. KT-lint, same sort of thing, can be used for formatting as well. Android lint, if you got to see Tor Norbyte's talk earlier, it's so cool, but it's also kind of slow, right? It's to be powerful, sometimes not as fast, but I'm really excited with what's coming there, and you have other tools like Sonar Kotlin. But these things, what they all have in common is they need to access not just the file and say, this is Kotlin code, but they need to understand it. And how do they work? This is not going to go in super detail, but you need an abstract syntax tree. What that is it's every word in your in your file and then kind of maps them to, okay, this keyword is actually a class definition, and this is a space between it, and this is a dot, and it kind of gives you the ability to traverse the tree. That's that programming interview that you had when you tried to get your job. It lets you traverse the tree and then figure out more about it. So in Kotlin, we use the PSI programming structure interface to do this. So you use the Kotlin embeddable compiler as a dependency, and then you have access to do this. And that parses the code into an AST representation, and you can traverse it for info. Then Tor mentioned in this talk earlier today at 1 o'clock, there's this new implementation of the Kotlin analysis API. And it was very interesting. It's the first I've heard about it, but what I'm going to parrot back from what I understood was, there's this new analyze function that's here, and I can't point at it, but it's in the blue in the middle there. So this analyze function allows you to give it a PSI element, so something that you parsed out, and it gives you extra information. And this is actually compatible with the older Kotlin compiler as well as K2. And so it's something that you can leverage in lint when writing lint rules, but it sounds like it would be a nice way to get more semantic information about your Kotlin files. Additionally, I did not know what FIR was a week ago, but I have been cramming for this test, and this is my test. But yeah, it's part of the K2 compiler. We've heard about this new representation that's there. It's a new semantic model that gets parsed with PSI, and then ends up creating this new model, which has a lot more information about what's actually going on in your code. This can also be something we can use to gain some of that context. So, we talked about a lot again, but remember I said this is a real-world story I'm going to take you through? So I talked to you about like that first problem I ran into, and now I've been there for a while at Square, and noticing that a lot of developers are having kind of a hard time creating these development apps. And the reason is because you have all these modules, and you want to create one isolated one, but it depends on other things. And when you use dependency injection, if you can't satisfy that dependency, sometimes you get a build error. So I figured, well, why don't we just surface where these are? Why can't I scan the code base with PSI, figure out everywhere somewhere is provided to the graph, and everywhere it's injected? And so that's what we did. So let's walk through it. Here's your error, missing Dagger bindings. Like, okay, why? It says missing binding network graph. I have no idea what this means. So let's go check it out. Let's see here. How do I get over there? All right, so we're going to go ahead and run this Gradle W app assemble, and we will get the exact same error that we had over there. Say, hey, you don't have a network graph. So I'm trying to build this app. It doesn't have, the dependency framework doesn't have it. So I can click on it. I can say, okay, cool, well, it's this interface. All right, well, I need an implementation of it. What are the implementations? Now I'm using IntelliJ's fun stuff. I look at type hierarchy. I see there's a fake network graph and a live network graph. Okay, I'm going to satisfy it with a live one. That'll be fine. But now I need to add that Gradle dependency, right? And so how do I figure that out? Well, I look at the project structure. I find where this file is. I see that it's in the impl of networking. So now all I have to do is go to my app, go to my build Gradle, and then I just have to go ahead and take that impl and add it into my app's configuration. And when I do, it now has an implementation on the class path, and it can work. That will pass, by the way. But this is challenging, right? There's multiple steps that happen there. And sometimes resolving dependencies and having things on the class paths is really challenging. So how do we surface these things? Like, I could do a text search, but in IntelliJ, there's not the concept of like understanding where Anvil bindings are given. I think there is a Dagger plugin that I haven't tried, but that might be a place where you could try to find these as well. But what module are those in? That doesn't answer that question either. So specifically, for my use case, I figured this would be nice to be able to surface this information to make it easier for developers to do. So we're going to continue with this demo. I got to see what's next. Okay. So how do we solve this? We're going to go ahead and scan our code with PSI to find all the places that we provide dependencies and where we consume them, we inject them. So we're going to scan all the source codes for the module. So this invert Gradle plugin basically hands you all the source code for a given module. You process it and you give it back whatever you've collected that will then be used by the report. You want to figure out where this type is actually provided, where it's injected, and then be able to explore the results. So let's do this. Let's implement it. This is the exact use case here of contributing a binding with Anvil. So what this says is I'm contributing this binding to the app scope. I'm taking a live network graph, and I'm providing it as the interface network graph. But in order for me to be constructed, I inject a user repo, category repo, a network config, and an HTTP client. Now, this makes your configuration really nice, but when you get into actually coding and having these errors, it's kind of hard. But this would be really hard to figure out. Like, how would we know what gets injected and what's not? Well, we can use PSI to figure that out. So I put notes here in case I forgot what files they're in. But let's go check it out. So this is the live network graph. OK, close this to the bottom. So this is exactly the code that we were looking at before. See if I can zoom in a little bit. So here's our live network graph. We inject things. But how do we, if we're going to go through with PSI and figure out what's going on here, how do I do it? Where do I start from? The documentation, very sparse. So you might find some detect rules or some lint rules or try to figure things out. But there's this nice plugin that you can install called PSI Viewer. And in PSI Viewer, it shows you the PSI tree for whatever's selected. So here I can go ahead and I can select the class. It'll select everything. I don't know how well the colors show up there, but it selects everything related to the class. I could go into just a single, here's the primary constructor. I can look at what's attached to there, but it gives me a good idea of what that structure, that PSI tree is. So when I'm traversing it, looking for the contributes binding annotation on a class, and then I'm looking to see if it has an inject constructor, I can figure these things out and then realize this is contributed as this. And while this is helpful, it's still kind of confusing. There's a member of my team named Rick Bersaro who does a lot of open source, including a lot of Anvil contributions. And he has this library called Static he's working on. And so I want to show you how I can look in there. So Kotlin conf. So instead of using PSI Viewer, this is the same code here. If you saw Tor's example from lint, basically you can just pass in the Kotlin code as a string, create a KT file. So this is the actual like PSI file, and then you can like traverse through it and figure stuff out. So if I was to do this now and say, for this file, traverse through and show me all the import directives, if I just printed it out, it would look like this. And it's not super helpful. You know, I could go further in and try to figure out like what properties are on here, it dot, and then, okay, PSI or parent, valid import. But what if you could use Rick's library and just say print everything? So this is available for everything that's a KT element, which is something that's a part of that tree. So what's really nice is you just literally put that for debugging anywhere. And then you get what I consider to be beautiful. So it is a really nice way of representing the PSI tree, really well colored. The thing that's nice about it too is in that tree that you saw in the IDE plugin, it would just show things like import directive. But when you're actually traversing through the code, you want to see the type of class, because that's the way you're going to be filtering things. And so it was a nice way for me to start like debugging and figuring out, okay, this is what I actually need. I'm at this point in the tree. What else do I need? So anyway, that's a really cool tool. In the slides that I'll publish afterwards, and in this, you'll see a little quick blurb of where you can get the snapshot and where that's hosted. Lastly, though, I want to show you, since we're live in the demo, what the FIR tree looks like, which is part of that K2 compiler. There is a FIR tree plugin you can download, and that's similar to the PSI plugin. But remember, FIR is like the semantic model one level over. And so over here, I can see the regular class is everything, but inside of here, I have all these declarations. And it's just this higher level model. It's not telling me about every single like word in here. It's telling me more about like, what is this thing in the code? And so it's a little bit easier to traverse over, to understand. And so this is going to be really powerful. You're going to see all the tools being built on this. I saw Nicholas Cordy's talk. He's the maintainer for Detect, about how they're going to pour all their rules from using old just PSI over to using FIR. I know that lint is using it now and stuff like that. So everybody's going to be starting to use it, and it's going to be really powerful to do analysis. All right, back to the slides. So we saw PSI Viewer. If you just want to spell it out, it's called Static, S-T-A-T-I-K, because it's a Kotlin library. There's a snapshot, but just check out Static. And then there's the FIR tree plugin itself. So let's go ahead and see what this looks like, right? We wrote the PSI code. I know I didn't go super deep, but nobody wants to be that bored. It works. So yeah, let's go ahead and see the demo. So we'll go out of here. And then on this project that I have here, I'm going to go ahead and run invert. Griddle W invert. And it is up to date, but don't worry, I'll rerun. And then what this is going to do is, I just needed it to print out the link for me. But inverts run. I write the data out as two formats. One is the standard JSON format of like, here's all the data I collected and combined. If you want to peek at one of these, this is one of the things up there. So like for the app, here are all the plugins. And for the models, here are the plugins. And anyway, all the data is kind of stored like that. I also have a separate representation with invert that's like a JSON format. And so, sorry, a JavaScript format, and that's what's used in the browser. So it's a little bit more optimized for key value lookups because it's harder to do. And anyway, so let's look at the report. So this is for our example project we have here. Inside of this, we can now go to my dependency injection explorer view. And inside of here, we needed that network graph, right? So if I had that error now, I could come in here and say, where can I find a network graph? And it would tell me it's provided in this module, networking fake, and at this impl, networking impl. So now all I need to do is use that, put it in my build Gradle, and like all those steps I went through are gone. And then I might say, well, is that really true? And then I'll click on it, and then it will take me to GitHub to exactly the lines that was defined. Because I've done that, so with this analysis, I've analyzed what Git repo you're on, what commit it was, what branch it was on. I know the line number, I know the file it was on, and with all that context, I can then pass you over to this other tool, the GitHub web interface, that can then give you more information, right? And because this invert tool, I want to run every time something lands on main, it should be like relatively fresh for everything that you want. Now, obviously you can run it locally like I just did, but the major use cases I would see is somebody would just go pull up the site that you'd have for your project. All right, so that is invert there. All right, going back to Svetlana's slide. So we talked about context and building that, and we've created this like custom context of where dependencies are injected and provided. And so with those, we've been able to create this new dynamic like exploration tool. JetBrains then put on the next part of the slide, the AI service. Because they have all this context and they can send it over to some AI service and it might answer your questions. But I think there's a key thing here is it won't always answer every one of your questions. The context that they're providing, and I'm assuming a little bit, is everything that IntelliJ has access to. So all of your dependencies, the usages, the definitions, a lot of the information you need. But it's not going to know about the specific libraries you're using. It's not going to know about the practices that you're using at your company, whether you have custom frameworks or the way you do things. You're going to have to plug that in some way. And invert is a great way to collect that and then make it explorable. So I'm not replacing it. I'm just saying you can use it to explore context, right? It's all about the dynamic exploration. And when you talk about an AI assistant, you're talking about, I'm going to ask one question, and then I'm going to ask another one. And that's the same thing here. If you have a tool that interconnects things, then that's kind of doing the same sort of thing. So we've talked about asking your code base a question. What other kind of questions could be asked? This is where it's kind of up to you a little bit. I would like some feedback, because as I'm working through getting this to be open source, like how you might use this in your company. One of the big things I start thinking of is when people are going through migrations, it's like, well, where do we still use that thing, right? So if you write a really quick analyzer, you could say, okay, we're still using this library and this module on these files. Now we can have a way to burn down, right? We can send it to product teams. But in general, I have a playbook that I'd like to go by, and we'll see how this plans out. But I would like to create like a plugin ecosystem, and you could kind of think of it like IntelliJ has plugins, right? You could put one in there, but it's very heavyweight to add to there. This way, you would just be writing like basically a Kotlin file, and then it would get a list of files that were in that module, and your job is to process it and create some sort of data. And so that data then gets passed as a JSON file over to invert, and you can explore it. So my thought is I've created one already that shows where are all the suppressions happening in my code. Because all of our suppressions right now from detect are actually in code, and there's no way to surface that. So how do I know where I have all these like detect issues if they're just in code and nobody ever knows? So that was one thing I did there, and you could create any sort of thing you wanted, like this way of defining dependency injections. I want the ability to create customized report pages. By default, I want to have some general structures of like, I'm collected this type, or I've done this sort of thing. Some more open-ended things, because honestly, being able to do something hacky and just get the insights and visibility is sometimes just what you need. You don't need to make this something that everybody uses. So I want to have that use case there. But if you want to, just like I did with the dependency injection report, I created a new type that I create, and I created a new composable report that has access to all the context that exists. I can look at all the modules, the owners, everything else that's there, and I can use it to like map my data together and make it more usable. I mentioned I want to make this so that every time you land something in the main branch, it's immediately available, and like something like GitHub Pages or S3. And one thing that was built in here that I made sure was critical is it supports deep links. So anywhere you're at in the invert tool, you can copy out the search bar, and anybody else can use that URL, and it goes exactly to where you were. And so that was critical because I wanted to be able to create shortcuts and things for different teams to be able to like just click this deep link, and it gets you it's basically your question as a query parameter. So that kind of sums that up. I'm excited to be able to show off the work I've done, why I did it, and I hope you enjoyed some of it. I'd love to get some of your feedback just to see like where this could go, and hopefully we can get it open sourced here and get some people using it. So thank you very much.